Okay, so you need to open the notes that I have in this announcement on Google Classroom. That way you can follow along with what I'm saying. We are going to talk about the normal distribution today. The normal distribution has some important features. One is that it's a bell-shaped curve. And also it is symmetrical about the mean, and the mean, median, and mode are all equal to each other. Your bell-shaped curve could be, it can be stretched or it can be squished. It can also be translated. So the normal distribution is actually a family of curves, and that is important to remember. And then this is the form that you will see, and I have to flip my camera really quick so you can see what is going on, if I can just figure that out. Okay, so what I'm showing you right now is a particular example. So this would be a normal distribution with a mean of 100 and a variance of 16, which means you have a standard deviation of 4. So that's just what that would look like. If you look at this slide, it just shows these 3 curves and how they are similar and how they are different. So they have the same exact standard deviation of 2, but they have different means. And since they have different means, that means that their centers are different, because their mean is their measure of center. But that's all that slide shows. And then on this slide, we are showing that we have the same mean, but we have different standard deviations. Because remember, standard deviation describes your spread. And so that is why we have what looks like a squished up graph in green, and then a fairly boring looking red guy, and then like a smushed down blue. That is because of the standard deviation. This blue guy is far more spread out than the green guy. And the reason we are talking about this is because normal distributions have special properties that allow us to find certain probabilities. Basically, no matter what your values for your mean and your standard deviation are, we will always know that the area underneath the curve is equal to 1. Just like how when you add up all your probabilities, you get 1. That is not a coincidence, okay? When you use the formula to find out what your probability is for a given situation, this is the formula you're going to use. That is a crazy messy formula, which is why we are not going to use the formula at all. We are going to use the graphing calculator. And don't worry, the IB people are totally fine with you using the calculator for all of the problems related to this, because I looked into it. They don't need you to use that crazy formula, although you can use it. These are all, like, you would just plug everything in there, and this is an exponent. So that is just one gigantic exponent right there. Right there. Okay. The super special normal distribution is called the standard normal distribution, and it's where your mean is 0 and your standard deviation is 1. And we are going to do some example problems where we find the probability that Z is meeting these requirements right here. So I am going to stop this and turn my camera around.